Yeah, I think the Jamie saved like best for last. So the topic of my presentation is the best practice of the sonar installation and the problems. Okay, here is the table of contents. And so basically I'm going to go over the typical application of Sornel the retaining wall and three the major tools to ensure the quality of the Sornel construction. And also like I'm going to go over like a Sornel retaining wall failure as well. Okay, so basically Sornel retaining wall is used for the the cut situation and also can be used cut shoring for the fill the situation or cut and the fill hybrid condition. So this is like a very typical like application for the Sornel the retaining wall. So this is like a typical the cross section for the Texas turnaround. So when we add turnaround at the at the bridge abutment, we normally cut the header slope and install the Sornel and build the Sornel retaining wall. Couple challenge or the constraint is going to be the Sornel should be installed through the existing foundation element. And also there will be the headroom constraint especially for the installed thumbnails. So sometimes we just like actual Sornel installation angle, typical installation angle is about the 15 degree, but you can use up to like a 5-degree angle. And also you can install the Sornel in segment. Also another typical the application is the widening of the roadway and or with like depression on the roadway as well. Also like the Sornel can be used for the temporary special shoring for the box culvert installation, or it can be used. This is a very the unique and the special case, but the Sornel can be used to reserve the foundation capacity the in-page construction. And also temporary special the Sornel used as the temporary special shoring for the fill retaining wall. So in this case, like the Sornel temporary special shoring is built at the end of earth reinforcement of retaining wall. Typically which is like MSCW. Okay, so this is a very special case, and I got the question a couple times in this month. Sornel hybrid wall. So in sometimes like you need to build you need to cut or build the retaining wall. So the existing ground is somewhat like if existing ground is somewhat like located between the midpoint of the top and the bottom of existing the retaining wall. So in this case, you want to consider the hybrid retaining wall. So basically, you build like a fill retaining wall on top of the Sornel retaining wall. So there may be like couple of advantages in terms of the construction is going to be way further. It's going to be faster than the building the temporary special shoring at the end of retaining wall, the field retaining wall and the field retaining wall. It may be a bit faster. We typically do not recommend hybrid wall with continuous face. So which means if you try to build, typical like the wall face like a precast panel face. So if you wanted to build the precast panel on the precast panel the face, with a continuous the face, crossing the Sornel and the MSCW. The retaining wall on the drainage system located at the end of the earth reinforcement as like under drain. And the Sornel drainage system is in front of the retaining wall. So it is not very hard to connect these two systems. So in most cases, the capacity for the drainage system in the Sornel wall, it may not be good enough to collect all the water from the retaining wall. So there's like a couple viable option. So once you finish like a Sornel retaining wall at the bottom, you can build this fill wall as the temporary earth wall. So basically you build the temporary earthwork. So our bridge standard call out the TW, RW, using the metal grid system. But in this case, basically you can build the TW, RW using the geogrid. So then you can install the soil nail through the geogrid temporary earthwork. So in this case, the geogrid, the RWTW will act as like a build-up. So typical build-up called out in the construction plan, there is like a limitation. It should be like less than like 3 or 5 feet. But if you have larger, if you need to build the temporary earthwork with a larger height, you can consider this option. Other option is you set the MSCW with some 2 or 3 feet offset between the interface between the fill and the cutter. So this like 2 or 3 feet interface can be used as the flume to in case that the retaining wall, the MSCW make the water, the flume can the flume can handle the drainage from the retaining wall. So these two options is viable, but we do not recommend the fill wall on top of a soil nail wall with a continuous face. Okay, the history of the soil nail wall in textile project, and the first soil nail wall in the textile project was built in the 1980. So we have like more than 30 years experience in the history, and it shows the very the satisfactory performance, and it used it has used for 30 years, and it actively used for 20 years. So in the last 10 years, clearly it shows increase in the quantity of the soil nail wall fascia and also the soil nail anchors. As you can see in the table, the soil nail retaining wall is typically paid two items. Item 423, which is a soil nail retaining wall fascia, and item 410 for the soil nail anchor, or the item 411, which is a rock nail anchor as well. Okay, so a couple important aspects of the soil nail construction, and so basically we have 3 tools to ensure the quality of the soil nail construction. So first, a contractor drawing, and the soil nail specification, and the inspection. Okay, let me talk about the construction drawing first. So soil nail retaining wall is not the proprietary system, which means the designer should provide full details. So typically the construction detail or the construction plan include the retaining wall layout, and it shows a basic, the basic dimension of the retaining wall, and the specific wall details, and also specific nail location details. We normally show the soil nail location details in the soil nail the layout. So as I said, this is not the standard. We do not have a soil nail retaining wall standard. It's not like RWMSC or the RWMSC DD. So the soil nail retaining wall should be designed per each site condition and the soil condition. So in the plan note in the soil nail layout has lots of information. So the inspector or the project manager should carefully review and go through all the plan note in the soil nail layout. Typically, a soil nail layout calls out the the maximum amount of the time that you can leave a nailed cut. So typically, once you cut, you need to the punch the nail and the grout and shoot the shotcrete next day. So the punching, grouting, shotcreting, including put the ankle plate and the bolting, it is 1 day, and cutting is another day. So if you just put a soil nail without any the shotcrete, the element, which means you just poking the chopstick in the soil. So it is not a system. The soil nail retaining wall only work as a system. You should have soil nail, and the structure face. Uh, so one of the typical observation is like one may want to order the, they do not want to order the, one may not want to order the the shotcrete half truck, or the, so less than like a 7 yard or 9 yard, and they want to install the nail and wait the next day and bring the shotcrete the other day. But it is not acceptable. You should punch grout the shotcrete on the same day. And the sewing nail, the location is typically shown in the sewing nail layout. Typically this sewing nail layout and the retaining wall layout is very important because this is like a base for the precast, the precast panel. The precaster uses this the geometry to produce like a precast panel. So this is very important. So if you review any shop drawing, so make sure the geometry shown in the sewing nail layout or the retaining wall layout the matching the actual site condition. Okay, the next tool is the sewing nail specification. So we have item 410 sewing nail, 411 for the long nail. This specification the control the material the sewing nail and the grout and also equipment and the construction method, drilling, grout, the spacing of the centralizer, and the anchor testing, and the measurement of the soil nails and the payment of the soil nails. So other specification include like a 423 like a retaining wall typically govern the retaining wall the fascia, and also like there is the specification for the pneumatically placed the concrete as well. Okay, so typical the drill rig for the sewing nail the retaining wall is like continuous the flight over. Some soil condition requires special tools, the soil conditions such as like a water-bearing sand and the gravel condition. Typically the hole is not going to be open during the construction. So in this case, you may need a special technique. Typically we use like hollow core bar. So basically hollow core bar, you drill. You punch the hole and the grout at the same time. So basically you do not need to worry about the hole stability. Typical price for the hollow core bar is like about 150% or the 200%, because you will need you are going to waste the lots of the grout during the installation. But if you see the site condition or soil condition during the design, you need to consider the adding like a note of the requirement for the cased hole or the hollow core bar. So avoid any any like conflict for the like change order. And also hole diameter. Typically we use like 6-inch or the 8-inch the hole diameter. So over may wear down. So make sure that you have like the hole the contractor install is like the size meeting the size called out in the construction plan. Also verify the nail length and make sure that there is the hole stability secured and the hole is open and clean and stable. It has like a lot of issues in this picture, but if you see like significant bar length is sticking out, so first you need to suspect the sewing nail length. So make sure that you have like a sewing nail length the called out in the contract plan. The typical bar for the permanent sewing nail is like epoxy coated the bar, and for the temporary the sewing nail, typically you do not need the epoxy coated bar. So epoxy coating is like first like method for the corrosion protection. Also, if you have a condition you anticipate like a severe corrosion environmental, you can use other class 2 or class 3 the corrosion protection system using the plastic sheeting around like the epoxy coated bar and with the grout, and also make sure that the centralizer is used with minimum spacing of 8 feet as per the standard specification. And also the thickness of the grout is very important. I'm going to show like other picture, but the grout should flow. If the grout is too thick, it may plug the hole. So there is like the risk for the hole is not going to be fully filled or grouted. And there's the two different grouting method. So first method is you install the grout tube and the epoxy bar together, and you pump like a grout, and once you see the return, then you pull the tube out. So this is the default method called out in the specification. If the contractor show the thickness of the grout is proper, they can try to fill the hole with the grout and stabbing the epoxy bar with the centralizer. So, but remember that the default grouting method is you install the grout tube and the epoxy coated bar together. As I said previously, the grout should be fluid. So basically like no shotcrete the mix can be used in the grout. Improper spacing of the centralizer is also the issue. The centralizer should be properly spaced with the maximum spacing of the 8 feet, and the tendon should be within 1 inch of the center of the holes. And this figure shows the tendon is almost at the bottom, which is indication that there is no centralizer support. So it's just hanging and hitting the bottom of the like a hole. And also, this picture shows, grout is way too thick and it didn't flow all the way to the end of the hole. So grout thickness is very important. Also, other issues like bird mouse. Bird mouse. So basically, you fill the grout by the gravity. So there is a small wedge portion of grout. So we call it like bird mouse or the bird beak. So we need to minimize this bird mouse. There's a couple different way to control the bird mouse, and one can use like a smiley face of the plastic, and you can put the smiley face at the face of the the hole, and you can dam the grout. Or sometimes you can use like the swimming noodle, just cut the swimming noodle and cut it half, and you can use the swimming noodle to minimize the bird mouse. One material that you shouldn't use is the soil. So basically, it is almost impossible to perfectly remove the soil from the grout. So do not use like the soil. Okay, so large bird mouse has like the issue. Basically you are losing like bonding. You are losing like the bonding capacity for the bird mouse. So if you install like 20 feet, there's like 5 feet bird mouse, and the actual effective the length is only like 15 feet. Small bird mouse can be just filled with the shotcrete. So once you finish like the grouting and shoot the shotcrete, and you can just like shoot the shotcrete into the hole. So which is like commonly used method. So for the like grouting, you should make sure the bird mouse is not excessive, and sometimes you require like second or the third the round of grout, which is a special technique. but it can be doable for the specialized soil condition like a silty sand or the wet silty sand. This is a the possible option as well. And there is like there is some area with the high the corrosive environment, then you can consider extra corrosion protection like a class 2 or class 3. And the small bird mouse is very important. And the shockrating, pneumatically placed the concrete. This serves as like a construction facing. So the shockrete or the PPC can be used to fill the bird mouse as well. So before shooting the shockrete, make sure that the proper the reinforcement is placed before shooting the shockrete. So make sure that we normally put the double mat of whaler bar behind the ankle plate. So make sure the whaler bar, if it is called out in the construction detail, make sure it is properly placed. And also make sure the thickness of shockrete. Typical thickness of shockrete is about 4 to 6 inch. And also you need to to put the ankle plate and tighten the bolt while the shockrete is green. So if you put the ankle plate too late, so basically you make like the point of contact between the ankle plate and the shockrete face. So you need to put the place when the shockrete is still flexible. Okay, so this picture shows the shockreting, and this is a somewhat bad example that they didn't complete like a build-up option, or that they put the plate too late, so it doesn't make like a perfect contact between the ankle plate and the shockrete. Okay, so final shockrete face. I hope they put the ankle plate when the shockrete is green. And also you need to make sure put the ankle plate and tighten the nut, and also make sure that the bevel washer installed to compensate the difference of the vertical wall and the solenoid anchor installed with a 10 or 15 degree. Ferment paste. For the ferment retaining wall, typically we use like a precast panel, or it can be the cast in place the fascia, or precast panel fascia, and the precast panel fascia is like most widely used like type of the face element, and sometimes you can use like sculpt gunite. So basically, you apply like 4 to 6 inch the first phase PPC, and you can shoot another another like a gunite, another PPC, and you can make like a smooth face, or you can the sculpt the PPC to obtain the whatever the aesthetic the detail that it is required. And the soil nail testing, this is a very important tool to ensure the quality of the soil nail retaining construction. So typically it should be performed before production nail installation. So the best location is like a best soil condition you need to verify. So the objective for the soil nail testing is twofold. You needed to verify the soil strengths, so soil nail and the existing soil bonding strengths, and also you need to verify the contractor's ability to install the soil nail without any problem. So sometimes it is allowed for the contractor to proceed the construction without the soil nail testing at their own risk. It is a somewhat risky approach, so typically we recommend making sure the run like a soil nail testing before the production nail installation. Um, so the if needed, I can contact our the office. We can provide like assistance for the solenoid testing, and also we bring our the load cell and to compare the contractor's loading system. So if need, I could contact our office. Okay, if test name passed, we can proceed with the production. But if there is the contractor should use the same the drilling method and the grouting as well. If you see the different soil condition or the site condition, the contractor needed to install the other the test nail and the test it. If the test fail, we needed to review the contractor's method and the material and the modify retest, and or we can check we can review the design as well. Okay. So this is like a couple like example for the soil the retaining wall failure. So this picture shows the marginal design and the poor drainage. During the design like phase, the actual the soil length is under designed, and also it didn't account the design didn't account the hydrostatic pressure, or the drainage system is not enough to carry all the water behind the retaining wall. And this site has like a previous the slope failure, and during the construction phase or the design phase, the the failed soil was not fully removed. So typically, all the failed soil should be removed, and you can use like either build up section, or install the nail and build up the in front of like install the nail. But in this case, it is somewhat ignored. So the retaining wall, solenoid retaining wall failed didn't because the designer didn't account the failed soil strengths. And this picture shows like poor construction practice or quality. You can see like the solenoid bars, and it should be fully grouted. So this is one of the example. This is one of the example that the solenoid retaining wall failed, and the solenoid length is what 30 feet, and after installing the 3 or the 4 rows of the solenoid, it failed, and as you can see, the out of 30 feet, you can see the grout only like 4 to 5 feet. So it is a combination of the multiple issue like the grout thickness and also poor construction. So conclusion, the solenoid retaining wall, it has like a long history of the satisfactory performance, the more than 30 years, and actively used for the 20 years, and it has a wider the variability of the project and the solenoid types. And to obtain the quality the solenoid retaining wall, we have 3 tools: construction drawing, and specification, and the inspection.